I will let you know if people can't see what you're sharing or if we're having trouble hearing you. So you don't need to worry about that at all. If I'm not bugging you about something, then it's working. And with
Awesome.
that, feel free to take, or actually, then I also need to kick it over to Normie. Jesse, is there anything you'd like to further do to introduce yourself or us?
No, I'll just do a quick introduction. I'm Jesse, a contributor to the Optimism Foundation. I run the ambassador program at the foundation. Ambassadors you can think of course. I'll do my kind of spiel. The ambassadors you can think of as the decentralized marketing arm of the Optimism Collective. And without further ado, we can kick it over to the Beam team to present. You can click on the screen that is being shared right now. That'll enlarge it so you can follow along. And of course, it's supposed to be interactive, so any questions that the community may have, please drop them in the chat, and we'll get to them at the end of the presentation. So without further ado.
Awesome. Thank you so much. Just a quick check. Can everybody see my screen?
Yes, we can. Intents
Awesome.
for smart contract wallets, what they are, and why we should do it.
Awesome. All right, let's get into it. Hey everyone, my name is Shahrukh.
And I'm Albert Brown.
We're from the team that built the Eco protocol and the Beam wallet. Today, we're going to talk about intents, specifically for smart wallet accounts on the OP stack, and show you some of the cool things that are possible with them. Before we get into it, I want to go over at a high level some of the topics we're going to be covering. First, we will talk about ERC-4337 and smart contract wallets. After that, we're going to jump into defining intents as they are today and what an intent-based architecture can look like at an application level. Then we're going to present our new way of doing intents for smart contract wallets. And finally, because we are at Optimism Demo Day, we're going to bring it all together and talk about how the system, at least in our view, builds towards a superchain. So smart wallet accounts are something we are all familiar with. If you've ever used a Gnosis multisig account, you have used a smart contract wallet before. These are smart contracts that give you most of the same functionality as a normally externally owned account. ERC-4337 standardizes these type of smart contracts and takes it a step further by creating a new transaction type called a user operation, which gets executed through a new singleton contract called the entry point contract. Smart contract wallets bring a host of benefits. And one of the main ones is that the smart contract wallet enters us into a new paradigm for accounts. In the current paradigm, any action for users needs signature validation, but with smart contract accounts, you can now incorporate state validation into your wallet using just a single signature as if it's an autonomous smart contract. This opens up a world of possibilities, and we're going to show you one such example in our presentation. But before we get into that, I'm going to kick it to Albert to give a high-level overview of the second key ingredient in this presentation, which is an introduction to intents and what an intent-based architecture looks like at the application level.
Thanks, Shahrukh. So, intents are a fairly complicated subject, but I feel like I'm going to intro it just with this tweet. It's a good tweet, funny tweet, I like it. But more importantly, intents are about users and a user experience. So currently, we live in an infrastructure where everything on chain follows this imperative archetype we have here. In essence, everything on chain must be done to the letter with everything specified, everything down to the very last piece of infrastructural decisions that must be made around the action. And simply put, users don't care about a lot of these decisions. Users just want the pizza for 20 bucks, and they want it there by a specific deadline, but they don't care how it got there, and sometimes even who bought it from them, or essentially where it even came from. Next slide, Shark. So to make this a little bit more real, let's talk about one of the most common user operations on chain, which is a swap. So intents for swaps functions in a very similar way to the pizza. You have token A and you want token B, and you don't really care like what goes on around getting your token B for token A, so long as it A meets your deadline, B meets your price that you want for the swap, and C you don't have to essentially wait like forever for it. So what this looks like for a person who is fulfilling the intent is that there's a smart contract that has token A in it, and they're allowed to do whatever they want so long as they get token B there by the end of the block. And so in that way, it's like kind of like it allows for things that we're more familiar with, like flash loans. But in general, it like essentially works in things like swaps into the modern MUD landscape. Back to you, Shahrukh.
Awesome. Thanks, Albert. So we just went over intents, but why does it matter for an application like Beam? Well, we built Beam for payments. We want to build something people without deep understanding of crypto can use for payments. We want to have a Web 2-like user experience in the front, but use Web 3 in the back. And we believe one of the key to doing this is abstracting away most of the complexity that you have when you're dealing with or interacting with the blockchain. Jim Keller has a fantastic quote that Carl mentioned in one of his talks. Shout out to Carl, that was a banger presentation. But the quote was, when things are beautifully done, usually there's a well thought out set of abstraction layers. And we've kind of like pushed that concept forward in Beam. We already have a few of these abstraction layers to improve the core user payment experience inside our application. We abstract away things like private key management through Shamir's secret sharing so that you can save access to your wallet using just your socials, but still maintain the non-custodial nature that you enjoy with a conventional wallet. We also abstract the concept of paying gas in the network token by using 4337 paymasters. And finally, we abstract the need to know public addresses using something called beam names, which are like extension of ENS, but on L2. And we built these layers of abstraction. After we built these layers of abstraction, the next challenge for us was to work on the next layer of abstraction, which was abstracting the concept of chains themselves. We want to support as many OP chains and other rollups as possible so users can have a great payment experience regardless of the network they're on. But although we envision rollups to be extensions of the Ethereum ecosystem, at the application level, these rollups don't have a great way to talk to each other. So when we are thinking of making products on top of these rollups, although you can design around most of the complexities at the application level, we realize that there are some cross-chain interactions that make it really hard to hold true to our product vision of making a truly chain-agnostic wallet. I want to make this point less abstract and talk about a concrete cross-rollup problem that we have in Beam right now and how we stumbled onto intents as a possible solution to that problem. So as I mentioned, we have something in Beam called Beam Names. It's an ENS-like service that basically gives users in Beam a username. This is really cool because anyone can pay some eco to register a Beam name and it becomes a pointer to your public smart contract wallet address. And this worked out great when we launched because we were only on Optimism. But when we started to get ready to also support Base and push forward this concept of chain abstraction, we ran into a problem. And the problem is that the Beam name requires a single canonical contract so that they are unique and that contract is deployed on Optimism. And we created a bridge for eco from mainnet to Optimism and from mainnet to Base. So we did have eco tokens on both networks, but for a user who had eco tokens on Base and wanted to register a Beam name on Optimism, they would first have to bridge out from Base, then bridge into Optimism, because that was the only way they could use the eco that they had on Base to register a Beam name on Optimism. And this path was clearly not feasible, because for a user to get a Beam name NFT, they had to withdraw from a rollup, wait 7 days, pay exorbitant gas fees on mainnet to finalize the withdrawal, and then bridge into Optimism, and only then could they do the registration. Needless to say, we needed to find another solution. So that's what we started to brainstorm on. So we went to the drawing board. We first started with exploring the most naive implementation, which was just to handle this off-chain. Users would send us eco with a message on Base, and we would register the name for them. This is clearly not ideal, it's trusted and centralized, and that's not why we're here. So although it served as a first step to think about what an MVP could look like, this concept was not the ideal end state that we wanted. The second thing we looked at was integrating with a bridge that can solve this for us so we mitigate the centralization risk and trust assumptions. Shout out to Christian, who's in the channel listening in. He did a lot of work looking at Stargate across layer 0, and the idea was that we'd use one of these bridges to move the funds directly from base to optimism and have a post-bridge hook to call register once the funds were on optimism. We made really promising progress, especially with the cross, and want to give a shout out to their team for helping us explore this path. And one of the third options we thought of was using an oracle. We could basically check to see if the desired registration happened on optimism and only then charge the user on base. But for that, we have to trust a new third party, and that has its own set of problems. And I want to show a POV of the Beam team a few days in after deep diving into all the potential paths and realizing that the utter chaos of creating a payment application that is chain agnostic, because it meant that we had to specify computational paths for any and every cross-chain interaction. We felt that there simply had to be a better way. And what we realized was that we've only looked at bridging because it was the most obvious computational path to get us to the desired outcome of registering a beam name that the user wanted. But the problem actually had two parts. The first was the desired outcome, which is what we actually want to do. And the second part was the computational path. How do we actually do it? And we asked the question, do we even need to bridge to satisfy our desired outcome? We realized that we actually didn't care about the path more so than the desired outcome, which is the general idea behind intents. So we thought, what if the user's wallet on base was somehow able to check if it got the beam name that it wanted on optimism and paid the eco to whomever registered the beam name for them. And this was great because now we don't care about how the registration happens. We've removed the need to bridge the funds as being the only option to register the user's beam name. As long as the base wallet could know the state of the optimism wallet, we could have the desired outcome satisfied regardless of the computational path. And that is the true power of an intent-driven architecture. So now if a user expresses an intent for registering the beam name Bob, it could be satisfied by doing some cross-chain bridging, or it could also be satisfied by a solver who had eco on optimism already and wanted to register on behalf of Bob. It could even happen as part of a rebalancing strategy for a bridge because it might be cheaper to register a beam name for Bob to get the eco tokens it needed on base versus bridging eco tokens into base from optimism. Like Albert mentioned, this is the flexibility that you get with intents. But there was the wallet on base know the state of the wallet on optimism. In the current landscape, the only options are to have an oracle or a message bridge, but if you do that, you're trusting a third party, and your security is as strong as your weakest link. So that is clearly not ideal. It was then that we had an epiphany. We realized that there was no need to pass the message because there was already another way for the wallet on base to know the state of the wallet on optimism without any extra trust assumptions because the message that we wanted had already been passed. And to go into the details of that and what that looks like at a technical level, I'm going to kick it back to Albert.
Thank you, Shahrukh. So if we talk about a system, we need to talk about the underlying base assumptions that go into it. And so when we described our Oracle-based solution, we were thinking of like a third-party Oracle or something bringing in, an extra partner. But there exists an Oracle already in a rollup based architecture, and that's the actual rollup itself. So let's talk about quickly before we get into our solution, just like what goes on when you bridge your funds out of an optimism based rollup back to the L1. So the first thing that happens is that on the L2 you create a transaction that marks the withdrawal, that withdraws the tokens, and that just burns the tokens. But it leaves you with an important piece of information, which is the transaction hash. See, all these transaction hashes are being propagated down to the L1 by the sequencer and kind of committed into this large state tree that's stored in this contract, the L2 output oracle. Your transaction hash that shows that you withdraw the token is your lookup key. And so when you're withdrawing your funds, you're doing that by submitting a, like kind of under the hood, a storage proof that shows that transaction's inclusion in the L2. And in doing so, that storage proof forces you to give the correct transaction parameters, which means that Optimism and the bridge is able to validate important parameters here, like which address is receiving the tokens, how many tokens are coming out, and what's the address of the token contract that it's going to. And so, in essence, this state validation is already being allowed by the sequencer itself, and there's no extra oracle required. Next slide, please, Shar. So if we look at how this looks in our system, we want a similar thing. We want a purchase or registration of an NFT on the L2 to then be validated on the L1. And so if we see a transaction be submitted on the L2 and then committed to the state, we can wait however long we want to make sure it's confirmed. But that transaction can then be proved in a almost identical way for its inclusion in the state tree. And that proof can check the input parameters of the transaction, which is where all the important decisions are being held here. It gives us the beam name that's being registered, like the specific name, to make sure that it's what the user wants. It gives us the address that's being registered for, and it also gives us the address that is registering the beam name, so there is somebody to be paid out for the fulfillment of the intent. Next slide, please. And so the only issue here is then propagating that information. And so on base, the intent module has to live, because in essence we're talking about a base to Optimism intent, but it could be any L2 rollup. And that module defines these parameters that are going to be checked by the storage proof. You know, the payment amount in tokens, which doesn't necessarily need to be the exact payment that's required for a beam name. It can be anything. The user can negotiate. But it does need to specify, you know, which address receives the beam name, what beam name it is, and it does need to specify a deadline so the tokens don't get lost forever in the intent if it's never fulfilled. And so when the storage proof is validated from the essentially the data in the L1 contract, what we're left with is just a need to send a cross-chain message confirming the validation of the storage proof to the module, and that would release the funds to the address that we said before was recovered in the storage proof as the person who submitted the transaction. But what if I told you that this cross-chain message doesn't even need to happen on L1? Next slide, please. By leveraging a new opcode that's proposed for Optimism, known as static call, contracts on Optimism-like rollups will be able to read data and essentially read any gasless kind of function call, read state data from the L1. And what that allows you to do is to do the whole proof. The whole proof only requires the knowledge of what's in the state tree of the Optimism contract, not any actual calls to the contract, nor any computation on the L1. In this way, we completely allow the two rollups to essentially communicate to each other by checking their work, you know, by checking their committed state on the L1. And all the computation, the hard computation of the confirmation of the proof, can be done at a much lower gas cost on whatever L2 wants to check state. And so in this way, we kind of use L1 as like a canonical message and a canonical state kind of record, but we don't really use it as a computational source because that's not really what it's for. And that's like the idea behind superchains, that chains can get their own speciality. Back to you, Shard.
Thanks, Albert. So in more simple terms, we can create an application where instead of doing an imperative transaction, we can create a declarative intent and give it to solvers to find the best computational path. For the application developer, it's much easier because we don't have to figure out routing to get the desired outcome our users want. We can simply use an intent language to specify what we want to happen, and it just happens in the background, and we only pay out the reward from our users once we validate the condition has been satisfied. Here we can see that the application just expresses a user's intent about getting the beam name Bob. The solvers figure out a computational path that gets the desired outcome. That gets validated by the user's wallet on Base by checking the same user's wallet on Optimism, and only once that condition is satisfied, the payment is given out to the solver. Throughout this whole process, the user never needed to do any bridging. And the most awesome part is that since Beam Names is an NFT contract, this solution can be generalized to work with any NFT on any rollup that supports static call. So once static call gets accepted into the OP stack, it will work with any OP chain. And isn't that what the superchain is about? Carl from OP Lab has done some great talks around this, which I highly recommend that you watch. He basically talks about how these rollups are individual islands on Ethereum, and through public goods like the OP stack and common standards like static call, we can create a superchain that has three distinct properties. The first is that no user should be subjected to bridging. Carl had a wonderful way of putting it in one of his talks. He said something along the lines of, bridging is lame, I like doing things, and bridging is doing a thing to do a thing. And with our proposed system, you don't even need to have direct bridges connecting the OP chains, because you can now validate the state as a precondition to paying out the reward through static call on the rollup that has the funds. The second is that it should have robust and secure modules. Here we are leveraging static call, which hopefully soon will be integrated into the public OP stack, which anyone can use. And our vision is to use ERC6900 style wallets so that we can create a plugin to enable this kind of interaction. Since it's a smart contract module, any wallet application that supports ERC6900 can simply add this plugin and unlock the ability to buy any NFT on any OP chain from any OP chain without having to worry about the chaos of user-facing bridging. It makes creating superchain applications much easier. And the final condition property was that we should offer near-free transaction. Here, because we are using static call to get a free read on mainnet and leveraging the fact that the sequencer already has to update the state, we only have to pay the cost on the rollup for validation, which is relatively insignificant compared to doing that on mainnet. We also envision this to either create a solver marketplace where solvers compete, which would hopefully drive this premium down, or solvers and even applications themselves may choose to subsidize this cost because there is some second order MEV that they can extract by ordering these solutions with other transactions. And this is why we believe that the superchain actually comes together at the application level, because by using these technologies, we can easily create an experience within an application like Beam that makes all these individual rollups act as one virtual chain. So, in closing, to recap, we talked about intents and 4337. We showed a hurdle in making Beam a chain agnostic product. We showed a solution to the problem using intents to remove user-facing bridging without compromising trust. And we showed how this type of architecture can ease rollups in acting like a single virtual chain at the application level to create a kind of superchain. And this is very early stages of our exploration. There are numerous open questions as we get into the nitty-gritty details, but we wanted to give this talk to inspire others to build applications leveraging these benefits of OP chains so that together we build towards the superchain vision. We wanted to show that it is possible. We see the light at the end of the tunnel, and we are so excited for what comes next. And that's a wrap. I would like to thank everyone for coming. If you want to learn more about what we're working on, feel free to go to our website or follow us on Twitter. Links are in the slide. And with that, I'll open the floor to any questions.
This is so good across every front. Can you just present every week? like, uh, so it's well structured. It's clear. You don't even have too many words on each slide. Props on that. Well stated. You told us what you were going to tell us, told us, and then told us what you told us, which is tremendous. Also, there's so much there to dig into. So I guess first of all, I would love to talk to y'all about being. We are some kind of alpha for folks. We're relaunching our documentation in like a week and a half. So if you want a sneak peek at it, you can go to docs.optimism.io. Please don't share that link yet, but that's what the new docs are going to look like. One of the things we did with the restructure is we want to be able to do more like course type stuff. And so more presentations like this where people can understand why they would want to use intents, how they can do that in the Optimism ecosystem. And the fact that y'all think Superchain first, it's so good. I have a couple of quick questions, and also props on being done at 8:35 when I said we'd start winding down at 8:40. Like I cannot say enough. You mentioned remote static calls, and we actually I'm not sure if y'all know this or not, but we just had a team finish an RFP to do an implementation of remote static calls in the protocol. We aren't at the moment it's not clear what the path is for integrating that into the protocol itself, but we are looking for really great use cases for it. So I would love to, I think y'all are connected with Annie. I'm gonna talk to y'all more about that because you might be able to help get that integrated into the protocol with the use case that you have.
We
anyways,
were looking, we are watching closely the efforts from System Clap. First of all, shout out to the team for doing an amazing job. It feels like we're following in the footsteps of a path that they already laid out. And they're the true pioneers who kind of built the core infrastructure with static call that allows us to do this. I think when we initially talked about this internally, we were like, okay, let's build this tomorrow. But obviously, we had to get it integrated into the OP stack. So yeah, as soon as it gets live, we're going to be the first ones out the door, playing around with it and making.
So I'm gonna follow up on that because knowing that y'all are eager for it for this exact use case, you can help make that happen. So, anyways. We should probably talk about intents. So I'm seeing if other folks have any questions, please do drop them into the chat. Just FYI, we do have the hard stop at 8:40. Might need to close up a little more abruptly than usual. But also, usually, Eco Team, this is where I ask, where can people find you? And you've already got that on the slide too. So what's next for y'all? How can the community most help you?
We're just excited to build towards the OP stack vision. I think the concept of creating infrastructure and tooling at the protocol level to make it easier for application developers like us to create this super chain, this single virtual chain vision. It just makes it so much easier for us as application developers to build these kind of applications. So happy to keep working with you guys and trying to realize this vision. Yeah.
Chain in chat. I have good news and bad news. Chain_L. The bad news is we have still not started recording demo days. The good news is this presentation was so good that I whipped up OBS in the middle of it and proved that I can record this. So I'm going to start making that happen. So we don't have this one recorded. Didn't ask permit. Oh wait, they got it.
They got it.
Y'all can just run it. Y'all can just take it from here. Go ahead.
Albert, there's a question from SolarJK. JK, if you want to take that one before we hop off, or do you want to circle back to it?
No, I can do that. Sorry, I'm just scrolling up.
It's at the last message.
Oh. Yeah, sorry. Yeah, no. So that's a very good suggestion. Yeah, the idea is essentially that we just want to use the minimal amount of L1 chain effort to move that data to the L2, and so yeah, until static call gets finished, we'll have to use a solution like that to essentially kind of boost the data from L1 to L2 before we can prove it.
That's a great suggestion, SolarJK. I hope I'm pronouncing that right. Did we have a hard stop, Barry, or
We
should I go
are.
through more of the questions?
So we can do. We have 3 more minutes of questions, but it will be a somewhat hard stop.
Okay, let's do it. Um, Going through a lot of chat, a lot of activity in the chat.
Y'all just. Yeah, I'm not seeing. I'm
I
mostly
see
seeing
a-
excitement and clarity.
I see this question from Weston. Um, he's asking, does this cross-chain messaging work for any chain? Does that team would like to enable or just OP chains? The structure that we're working on is just for OP chains, but I don't see why this wouldn't work for any kind of chain that commits its chain data to some sort of like central chain, or essentially not even central, but just some other like chain that's being used. I've heard of like essentially L1 chains trying to commit their transaction data to other L1s as like a way to ease bridging, and so that kind of thing would allow for this kind of architecture as well.
Yeah, to Albert's point, like any rollup that has static call enabled and is posting their canonical transaction chain contract, like appending or settling on Ethereum, it's basically going to be able to use this kind of architecture.
And
That's
that pattern can be like kind of extended, essentially. It doesn't need to be an L2 chain. We really just need the data settled to another chain to allow for this kind of essentially bridging of the data, because the data is what essentially allows you to prove the inclusion of
and
the
that's
transaction. Yeah.
that's like the cool part of the OP stack, because any chain that joins the collective is basically going to already integrate with like the OP node, and it will already have static call enabled. So for us to easily support any OP chain, we don't have to worry about each specific chain because they're all part of this collective. We can basically support any OP chain out of the box because they all share a common standard. And this is like the core premise of what Optimism is trying to do by like making these public good like an OP node that anybody can fork and reuse, and having these common standards. You can unblock application developers like us to like support as many rollups as possible without going into the nitty-gritty details of each rollup and their specific interactions, if that makes sense. Great question, Weston. I think that's a hard stop, Maddie, so we'll just end here.
It is indeed. Y'all are amazing. Please follow Eco. So much more to come. Excited for the recording, which apparently exists. So thank y'all. Excited for more.
Shout out to Dave for recording. Thanks so much, everybody.
Bye.